This conference will now be recorded.
All right, as I said, I'm Margaret Mooney and Vicki Gorman's on co-presenting, and we are sharing information about a virtual science fair next spring. As most of you probably know, we have two new amazing weather satellites. The first one was GOES-R. It launched in November 2016, was renamed GOES-16 when it reached geostationary orbit, and is now our operational GOES-East weather satellite. And then this last March, GOES-S was launched. It was renamed GOES-17, and in January of next year, it will become our operational GOES-West satellite. This is just a picture of the instruments on the GOES-R series of satellites. There's 5 amazing instruments, but this virtual science fair is going to mainly be using data from the Advanced Baseline Imager. So one of the Earth-looking instruments called the ABI instrument. So the ABI, compared to our classic GOES that's been observing Earth for the last couple decades, has 5 times faster coverage, 4 times better spatial resolution, and it can measure 3 times more spectral bands. The previous imager on the geostationary weather satellites measured 5 wavelengths of the electromagnetic spectrum. ABI measures 16. So Vicki and I have been part of a group called the GOES-R Education Proving Ground, where we've been trying to get teachers using the data. So there's lesson plans available on this site. There's a lot of resources available for teachers. Well, now we want to get students using the data. And so that's why we have this virtual science fair next spring. So there'll be 3 winning teams, middle school, high school, and then the first 2 grades of college. And all the team members will get an official invite to the GOES-T launch. That's the next satellite in the GOES-R series of weather satellites, which is kind of cool. We're not going to pay anybody's travel expenses, but if you get an invite, you can bring 3 other people, and you can go to Kennedy Space Center for a day before the launch, the day of the launch, and the day after for free. And then the students will also get $25 gift cards. The coaches of those teams, the teachers, will get their travel support to go to the American Meteorological Society Centennial Meeting in Boston in January 2020 to present at the Education Symposium. And that's a pretty cool event too. So we'll be accepting entries next March, and teachers can coach as many teams as they want. I'm going to go right to the webpage now. And Vicki's going to present.
Hi, everyone, and thank you so much for joining us this afternoon. I know we're getting close to the holiday season and you guys are busy, and we appreciate you giving us some time to talk about this great event. What makes it great are the satellites themselves, because every student, actually everyone, every citizen should know about the GOES-R series satellites, because basically weather forecasting has been revolutionized, and it's really exciting what the satellites can look at by using the Advanced Baseline Imager, or the ABI. So what you see here in front of you is a page that will give you some information, and we'll populate this as we go along. I think, why don't we go to projects, Margaret?
Projects.
Okay, so potential project ideas. So when you get to this page, you will see some basic information about what is required of your teams to enter the virtual science fair, but then there's some potential project ideas. In some cases, teachers may not use satellites on a regular basis in their classroom. And so we didn't want to make this difficult. We wanted to make this a very meaningful experience for both teachers and students. As we go along between now and the end of January, that list of potential project ideas will be populated further. So please check back often to see what we've put up there. And of course, if you have any great ideas, let us know, and we'd be happy to put it up there as well. One of the things that you might want to take a look at are if you go to the link that says ABI Bands Quick Information Guides. And here, the guides themselves you can read. They tend to be a little bit more scientific as opposed to more or an easier read for a middle school student. But there is another link on this page that says an additional set of operationally focused ABI band fact sheets. You can see where it's being clicked. And for example, if you go here and you go to baseline cloud top temperature, you will see this handy dandy sheet that will give you amazing information in language that your students can understand. So let's just say we look at cloud top temperature. If you go down to the middle of the page, it tells you what ABI bands are being used. And then it tells you primary application. Now it does this for many of the products that the ABI produces. And in this case, this is a principal application for monitoring convection. So you could key on a storm that's happening. You could go back to a storm that's happened since GOES 16 and 17 have been up monitoring the atmosphere. And you could compare the convection in that area and then take it down to a level that your students can really relate, and maybe get some newspaper clipping, well, not clippings, but online news stories. Look at the alerts and warnings that the National Weather Service alerted that day. You might even want to try to get some on-the-ground eyewitness accounts, maybe connect with a school in that area, so that not only do you see how the satellite was able to give almost real-time information about these highly convective thunderclouds. And I'm just using that as an example, maybe with a tornado, linked to a tornado. But you can also see then how that affected people on the ground, and the fact that this technology gives people advance warning. So it saves lives, it saves time. It's just so important. So anyway, if you look at those guides, any of those guides, they give you the primary application, and I've got a whole list of things that I'll populate to the site to suggest similar type projects. So if we go back to the page, or guidelines page. Okay. And now let's go to the middle school scoring rubric. Now, this rubric was designed for the reviewers, obviously. However, it also was made with the teachers, you guys, in mind, and your students, so that you understand what's actually expected of you. Now, I'm not going to read through everything, but I am going to highlight the sections. There are 5 basic sections. Section number 1 is the poster template. We're going to be using a scientific poster. Now, those of you associated with GLOBE may have done this before, but in a lot of cases, students don't make a scientific poster until undergrad or even sometimes graduate school. So this is an outstanding opportunity for students to actually work with a poster. There will be a brief oral presentation. It'll probably be an EduCreations video that will be posted to our website in January, so that you can look at it, and it will give you very basic information as to how to do a scientific poster in case you're not used to it. But you can see in section 1, it talks about what should be included in your poster and the basic template. Please notice 1D, which says that you need to include some Ghost 16 and or Ghost 17 imagery. If that's not included in the poster, you'll take a hit. Plus, that defeats the whole purpose of what we want. We want kids or teams to score really well, but we also want them to understand the importance of the GOES-R series satellites. If we go to section 2, Section 2 is the title, the abstract, hypothesis, research question. In some cases, you might prefer your students to use the hypothesis. In other cases, just a basic research question might fit the bill. So there again, it gives you some guidelines on how long the title can be, how long the abstract should be. If we go to section 3, so there, these are methods and procedures and results. We're interested in if any mathematical calculations were used to analyze the data. We would like to see tables, graphs, definitely imagery. That I think would be the most meaningful for everyone, and that the data presented are sufficient to answer the research question. The additional note is that you can have one page of supplemental material that you would upload when we have the final upload box open. And that's in case the students have a ton of data and they weren't able to fit everything on the poster, but yet they want the reviewers to see just how much work they compiled and how much work they did. In section 4, and you'll notice when we get to section 4, if you go to the third column, it talks about a weighting factor. And as we've gone through this, each section is weighted differently. This section here is weighted the most out of the sections that I've already spoken about, because it's extremely important. If you look at 4D, a lot of you are familiar with the terms claim, evidence, and reasoning. And so even if you don't use those terms as such, as long as there's good claim, evidence, and reasoning logic being used, that is really important. And this is kind of where the students get their teeth into, what exactly did we do? Why did we do it? What does it mean? And what can we do in the future? If there's a note there that says if your team works with a mentor, it can be mentioned in this section, and the impact of working with a mentor should be included in the video, which leads me to the last section, which is section 5. And I know I'm going over this rather quickly, but you guys can read. And of course, if you have any questions, you can notify me or Margaret. But the video is an 8 weighted factor. This is where your students and all team members have an opportunity to shine. They don't have to be seen on a video. It could be a narrated PowerPoint, but every team member should get the opportunity to present. The students are going to present the poster just as they would if they were in a poster session to somebody coming up to them. The video can be 8 to 12 minutes. It doesn't have to be perfect. We're not looking for perfection, but we are looking for evidence of rehearsal so that we know the students understand what it takes to do this. And just that there's a story told and that the video enhances the poster experience. So again, that's the sheet that the reviewer will be used. That's the sheet that you guys should look at when you're putting all this together. And the only other thing I'll say is I think that if you keep in mind all the 21st century workforce skills that we've talked about since the 21st century began, if you include that as you're going through this, then you will really get a great experience, not only in the research, not only with getting an appreciation for GOES-R series satellites, but also for producing better little junior scientists and better people through this whole experience. And thank you, and that's all I have, Margaret.
Thanks, Vicki. That was great. And Vicki made that scoring card, which is fabulous. The rubric for middle school and high school is the same. The college we don't have done yet. And I'll say that the only difference between, or the main difference between middle and high school and college is that for the college level classes, we want students to download the data and analyze it using a visualization software. We have several of examples of free software linked from the page. So in the interest of time, I think I'm going to wrap it up. If anyone wants to ask a question, we'll take questions now. Thank you for tuning in.